need for smart city. Preventing a problem is better than fixing it. The growth of a city directly means the growth of the people living in that city. So, this project mainly aims at automating a city with various kinds of features that improve the life of both people living in that city and also the people who are new to the city. Some of the problems which we face in the day-to-day life living in a city are as follows. Traffic jam due to inefficient and ineffective traffic control system, problem of money exchange in buses, violation of traffic rules by the people, accident met by the pedestrians while crossing the roads, problem in finding the destination for the newcomers to the city, lack of security of the people in public places. The project mainly aims at eliminating the above problems and helping the people of the city to have a smart and better life. Features of our project provide solution to the above mentioned social issues. We have included the following features: smart traffic control system, introduction of smart card systems in the buses, smart speed governance of the vehicles, smart guidance to the newcomers of the city, smart security to the public. This is our fourth feature, the smart traffic control system. In this, we use image processing technique to measure the density of the road and set the time accordingly. This will help to reduce the traffic delays and time allotted for empty roads. In this feature, our approach is we have fixed a camera to the stepper motor which rotates at 90 degrees 4 times to take the 4 roads. Let's see the output of the webcam. These are the 4 roads that are covered by the webcam. We are going to process this image to get the output. Okay, this is what we do in the Vision Assistant. We have the sample of a road with cars present in it. We use edge detection algorithm to find the number of cars present in a road. We use a number of edge detectors at various stages of the road and measure the first and last edges covered by those detectors. Then with the help of caliper, we measure the pixel distance. Then we sum up all the pixel distance and divide it by a threshold. We can determine the number of cars present in that road, and the timing can be allotted according to the density of the road. Okay, this is the demonstration of edge detection. We use edge detector at various stages of the roads. This is the first edge detector. We can fix a length to the detector. It will be adaptively finding the first and last edge of the cars or bikes that come under that detector. We use simple edge tool and we look for first and last edge. Since we want a value intermediate to 0 and 255, we use 127 as the threshold value. This is the demonstration of how to use the caliper. After finding the first and last edge using edge detection algorithm, we find the distance between those two edges by using the caliper. By measuring the distance between the two edges, the density of the road can be calculated. This is our first feature, smart guidance to the newcomers to the city. This is the front panel. This is the block diagram of our feature. Let's execute the program. First we have to enter the address of our destination to the place where we want to go. Now if we run the program, the details given by the users are processed, and the details such as the map of the place and the bus details are provided by the lab view, and finally the printout is taken. Now you could see the printed hard copy of the details. The second feature of our project, smart card system in buses. The objective of this feature is to eliminate the problem of money exchange in buses. We have used the RFID tag as the smart card and the RFID reader as the smart card reader. These smart card readers will be installed at the entrance of all the buses in the city, and the each smart card are unique to the citizens. They can use this to transfer the money for traveling in the buses. This will eliminate the problem of money exchange. Since smart cards are unique to all the citizens, they can use this smart card to travel in the buses. They can transfer the money for their ticket from their bank account. Let's go to the program. This is the front panel of the program. The block diagram of the program is okay. Let's execute this program. First, the from and to of the journey should be typed. Then the smart cards are used to read the details of the citizens. Then the program is run. The details of the citizen are provided along with his actual bank balance and the current bank balance after the money for the travel is subtracted from it. Now let's check with the other smart card. You see the name has changed. This is our third feature, smart speed governance in vehicles. In this feature, we control the speed of the vehicles at the variable limits. That is, for national highways, state highways and district roads, we have different speed limits. This is achieved by controlling the petrol flow into the engine. Here we have used a fluid meter to demonstrate this. Our third feature, smart speed governance in the vehicle. The objective of this feature is to control the speed limit of the vehicles
according to the type of the road in which it is going. For example, in national highways the speed limit is 100 kilometers per hour. In the state highways the speed limit is fixed to 70 kilometers per hour, and in district roads 50 kilometers per hour. We have used a fluid controller to demonstrate this. When the controller's lever is fully down, the petrol flows fully into the engine. When the lever is fully up, the petrol flow is completely stopped. So we have used a servo motor to control the flow of the liquid here. Let's go for the programming. This is the front panel of the program. The block diagram of this is okay. Let's execute this. Here we have used the RFID tag for varying the different types of roads. Let's see, for this type of card there is a speed limit, fixed speed limit, and for this card there is another speed limit and another speed limit. According to the type of the road, the speed limit changes. Through this we can achieve a variable speed limit.